Hi class, in this video I'm going to be talking about how to create a table of value and an equation from a pattern. So in this example I have a pattern here where I have figures 1, 2, and 3 and the number of blocks in these figures. So I'm going to create a table of value based off of the figure number and the number of blocks. Okay, so let's start with that. I'm going to start at figure number 1. I'm just going to draw 1 here, and I'll show you guys why later. I'm going to draw figure 2 here, and then figure 3 here. In figure 1, I have 1, 2, 3, 4, 5, 6, 7 blocks. Now in figure 2, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 blocks. And in figure 13, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 blocks. Okay, so it looks like there is a pattern forming here. It looks like as my figure number increases, I'm adding 4 extra blocks. So it looks like you can see that here as well. Looking at figure 1, it looks like we added an extra 4 blocks when we get to figure 2. And looking at figure 2, it looks like we added an extra 4 blocks for it to become figure 3. So that means figure 4, we would add an extra 4 blocks as well. So if we were to have figure 4 here, my number of blocks would be 19 because I'm adding an additional 4. Okay, great. So we just created a table of values for our pattern here. And also another way to write this table would be to write it as X and Y. I typically write tables as X and Y, where X would represent the horizontal and Y represents the vertical. In this case, X would represent my figure number, and Y would represent my number of blocks. So if I were to have a coordinate grid like this, where typically it is going to be X for the horizontal and Y for the vertical, I would have a coordinate grid where instead it would be X is my figure number. So I would say the figure number, and Y would be the number of blocks. So again, X would represent the horizontal, and Y would represent the vertical here. So in this case, that's what it would represent. Okay, so alternatively, I could also write this as 1, 2, 3, 4 for a number of for figure number, and then 7, 11, 15, and 19 for a number of blocks. Okay, great. So aside from that, I have 2 questions here to answer. How many blocks would there be in figure 5, and how many blocks would there be in figure 20? To answer these questions, I'm actually going to create an equation to answer it instead of just answering from the table. Now, if I were to answer from the table, figure 4 has 19 blocks. That means figure 5 should have 19 plus 4 is 23 blocks. So in theory, I already know the answer to the first question that they've asked me, right? The answer would be how many blocks in figure 5? I would say 23 blocks in figure 5. Okay, and the reason why I want to create an equation instead is right now they're asking me some easy questions. How many blocks in figure 5? How many blocks in figure 20 is also doable. You would just extend your table of value and move your figure number down to 20. However, if they ask me how many blocks in figure number 899, then it gets a bit more tricky, right? So that's why we want to create an equation for it. So to create an equation for this pattern, if this pattern is linear, I can create this equation. So this pattern is linear because it has a consistent pattern. As long as you have a consistent pattern, you can use this equation. So this equation is going to be y equals to mx plus b, where y and x are just the values that you see here, but the important ones are going to be the m value and the b value. Okay, so they do mean something. So let's talk about what they mean. So the m value is the Yeah, this might be a bit large here. Okay, there we go. The consistent pattern, or we call it the slope. That would make more sense when we look at it from a graph's perspective. Another name for it would also be rise over run. These are all the names for our coefficient in front of x. We either call it the consistent pattern, the slope, or we call it the rise over run. And we'll dive into why we call it the slope and rise over run when we start graphing this equation onto a graph. And now for the b value here, we have a name for it as well. We would call this b value the value of y when x equals to 0. The value of y when x equals to 0. So in this case, let's say I want to find my m value. What is the consistent pattern in this table here? It looks like it's plus 4. So I'm just going to say m equals to 4. Let's say I want to find the b value. Well, what is the value of y when x equals to 0? So remember, x is going to be my figure number. So right now, okay, to find the value of y when x equals to 0, let's let x be 0. What would my number of blocks be? Now notice that I'm increasing by 4 each time. So would it make sense for me to have a number here where if I increase by 4, I get 7? So let's just subtract. Let's go backwards. 11 minus 4 is 7. Then 7 minus 4 is going to be 3. And is it true that 3 plus 4 gets me 7? Yes, absolutely. So 3 would be my value of y, in this case number of blocks is y, when x equals to 0. So I'm going to write b equals to 3. So now when I write this equation out again, it's going to look like this. It would look like y equals to 4x plus 3. So again, y equals to mx plus b would become y equals to 4x plus 3. Now, how does this equation help me? Well, if I were to just substitute in my figure number, which is 5, right, in lieu of x, I can solve for question B and C. So let's take a look at this. So let's say instead of writing 4x plus 3, I'm going to write 4 times 5. So remember, 4x means 4 times x. So instead of writing 4 times x, I'm going to write 4 times 5 because my figure number is 5 and figure number represents my x value. So I got 4 times 5 plus 3. Well, 4 times 5 is 20, and then I still have to add 3 to it. So in this case, 20 plus 3 is 23. So y equals to 23 when my figure number is 5, and y represents my number of blocks. So I got 23 blocks in figure 5, just like how I did it here. But notice how when I use the equation, it's more useful if I have a very large figure number and I don't have to count using a table of value now. So let's look at figure number 20. In this case here, I'm going to use 4x plus 3 again. However, my x becomes 20. So now I have 4 times 20 plus 3. Well, 4 times 20 is 80. So I have 80 plus 3. And 80 plus 3 is going to be 83. So my y equals to 83. In this case, y is my number of blocks. So I can say that I'm going to have 83 blocks in figure 20.